Hey guys, welcome to lesson 3. Let's get started with the warm-up. It's giving us the graph below represents the velocity v in feet per second of a particle moving along the x-axis over the time interval from t equals 0 to t equals 9 seconds. So again, the first thing to identify anytime you're given a question is what kind of graph is it? Is it a position graph or a velocity graph? Here, if you look at it, it says up here also it is a velocity graph. So you want to be very careful. You cannot look at the two graphs the same way because the reasons are the same, but how we use them to find things is different. So part A says at t equals 4 seconds, is the particle moving to the right or left? Explain your answer. So again, as I said, the justifications are the same. It's how we gonna find it. So whenever we talk about, this is the velocity graph. So when we talk about our right and left, we say it's moving to the right when velocity is what? Greater than 0. Left when velocity is less than 0, right? So when is the velocity at 4? What's happening? At 4, the velocity is what? Is 6. The numerical value actually doesn't matter to us. Is it greater than 0? Yes, it is. So it is moving to the right. Therefore, moving right. Over what time interval is the particle moving to the left? Explain your answer. So by definition, what does moving to the left means? Moving to the left means that my velocity is what? Less than 0? Or can I say the negative, or where do we have negative values for velocity, or where is it below the x-axis? So which would be what? From 5, if you can see it clearly, it is 5. You can just count it up. It's 5 to 9. So, oops. So it is from 5 to 9, this interval, because this is where velocity is less than 0, right? See, at t equals 4 seconds, is the acceleration of the particle positive or negative? Explain your answer. Again, what is acceleration? It is the rate of velocity or the derivative of velocity. So what are we going to do? We look at the slope, but we don't write the word slope. Remember that. So we're going to look at the slope of the graph at 4. So is it positive or is it negative? So the slope at t equals 4, it's going down, so it is negative. So means what? The velocity is decreasing. It means acceleration has to be negative. So let's write that down. A of 4 is what? V prime of 4, which is what? Negative. Again, please do not use the word slope. You cannot use the word slope. But we do use slope to determine from the velocity graph what's my acceleration. And explain your answer. Velocity is what? Decreasing. What is the average acceleration of the particle over the interval 2 to 4? Show the computations. So again, average acceleration is what? Your rate of change of velocity. Please note that. That is your rate of change of velocity. And how do I find my rate of change? It is s of b minus s of a over b minus a. So it'll be what? Here, this would be v of 4 minus v of 2, 4 minus 2. What is v of 4? It is 6 minus 9. You can look up on your graph. Equals 2, which is negative 3/2 feet acceleration. Remember, let's do the units. It is the y-axis units over the x-axis units. My y-axis units, my velocity units are what? Feet per second. My y-axis units are feet per second. And my x-axis units are second. So it's feet per second over second, which is feet per second square. So the third thing that I want to talk to you about was the acceleration. Remember, the first derivative which acceleration is the first derivative of your velocity and second derivative of your position function. So the acceleration of a particle is represented by a of t, which is v prime of t equals s double prime of t. The acceleration function represents how fast velocity is changing, or at the rate that is the velocity is changing. And things to consider: if your acceleration is positive or greater than 0, then velocity is increasing. If your acceleration is less than 0, then velocity is decreasing. If velocity and acceleration have the same sign, does not matter, they can be both positive or negatives, then the speed is increasing. And if the velocity and acceleration have different signs, then the speed is decreasing. Remember, justifications are sometimes worth the same point, so we need to know how to justify using these explanations. That's why it's very important to know your vocab very well. Okay, let's get started with number 3. Again, the first thing that you are given is a graph. You need to identify the graph. What is your graph? Your graph is a velocity graph, right? It's not a position graph here. Remember here, if it's a velocity graph, your y values represent velocities. And your slopes are your acceleration. That helps you find the answers, or the answers to the questions you're looking. So it's as telling you the graph at the right shows the velocity v equals f of t of a particle moving along a vertical line. A. At what times is the particle at rest? Show the work that leads to your answer. So by the definition, when is a particle at rest? When my velocity is what? Equal to 0, right? My velocity, I'm going to write it here, is equal to 0. So basically, I'm going to be looking at where my v of t 0 is at 1, and it's like kind of approximately 4.2. So it is at t equals 1 and approximately equal to 4.2 seconds. Part B. When is the particle moving up, down? Justify. So moving up is same as moving right. Means what? My velocity is what? Greater than 0. And down means left. This is left, right. And velocity is what? Less than 0 or negative. In other terms, we can say when is the velocity velocity is greater than 0 is above the x-axis and less than 0 is below the x-axis, right? So let's look at our intervals. So from 0 to 1, it is what? Above the x-axis, so velocity, the particle is moving to the right or moving up. So 0 to 1. I'm going to use soft brackets for 1 because at 1 it is equal to 0, not greater than 0, right? And then where else is it? I'm going to examine from 1 to 3, or I would say 4.2. 1 to 4.2, it is my y value is negative. Again, I'm going to use soft brackets because at 1 and 4.2, my velocity is not less than 0, it is equal to. So I'm going to use soft brackets for those. And it is greater than 0 from 4.2 all the way to 6. Right? And our justification, we already wrote that. Part C. At what time is the particle moving at its greatest speed? Again, it's the absolute value of velocity. What are we looking at? We're looking at when the graph is farthest from the x-axis. We're going to be looking in both the positive and negative direction. right? Because speed has nothing, speed is always positive, it's the absolute value. So the farthest we look here is at what? T equals 3. So when is the particle moving at its greatest speed? Is at t equals 3. So let's write this down. When graph is what? At the farthest, is farthest from x-axis. D, during what time interval is speed increasing? So here we are going to be comparing our velocity and acceleration. Whenever we talk about speed increasing and decreasing, we are going to be talking about velocity and acceleration. If they both have the same signs, so if velocity and acceleration have same signs, it is going to be increasing. Let's write this down. Increasing when velocity and acceleration have same signs. Decreasing when velocity and acceleration have opposite signs. One is increasing and one is decreasing. So let's look at between 0 and 1. My velocity is what? Above the x-axis, so velocity is positive and my acceleration is negative, right? Remember again, velocity is your y value and slopes are your acceleration. So from 1 to 3, my velocity is also decreasing, my slope or my acceleration is also decreasing. So what will happen? Your speed is going to be increasing here. So this part, the speed is decreasing. This part or this interval, I would say speed is increasing. We're going to write it down once I finish that. Then from 3 to 4.2, it is what? My velocity is negative, but my acceleration is positive because I have a positive slope here. And from 4.2 to 5, my velocity is above the x-axis, so it's going to be positive. My slope is increasing, so my acceleration is also positive. So it means what? It's increasing here. I'm going to write increasing, decreasing. And from 5 to 6, my velocity is above the x-axis, so it's positive, but my acceleration is what? My slope is 0. It's at rest, right? So it's 0. So it's neither at that interval. So the intervals where it is increasing are 1 to 3 and 4.2 to 5. It's decreasing on the intervals from 0 to 1 and 3 to 4.2. Okay, so the last one. During what time interval is the acceleration the greatest? Again, acceleration is what? It is the rate of velocity, right? It's the derivative of velocity, or you can say, so where does it have the highest slope? So this is acceleration is greatest wherever you have the highest slope. So that is on what interval? It is over the interval of 3 to 5, right? So there you go. So that's your interval. So now let's try to do example 4. It is very similar to the previous example, but there are a few more things that I want to talk about. So it says the graph above shows the velocity function. Again, this is a velocity function graph, and it is moving along a horizontal line between 0 and 6 seconds. On what intervals? I'll just want to cancel this out. On what open interval? Okay, or you? Yeah, I want to cancel it out. Or what time t is greater than 0, less than 6 is the particle at rest. Justify. So again, by definition of when a particle is at rest means what? I'm talking when my velocity is equal to what? 0. Or where it hits the x-axis, right? So where is it hitting the x-axis? At t equals 1 and t equals 4.2. So t equals 1 and t equals 4.2. Now on what open interval is the particle moving to the right? Again, go back to your definition. What is the definition of particle moving to the right? It is when velocity is greater than 0 or positive, or where the graph is above the x-axis. So what do? Look at the intervals where it is above the x-axis. It is from 0 to 1, right? It's from 0 to 1, and then from 4.2 to 6. To 6. C. On what open interval or at what times is the particle moving at its greatest speed? And greatest velocity. So these are two different concepts. Greatest speed means we want to find the farthest away from the x-axis. So greatest speed is where? At t equals 3. Yes, because it's furthest away. So greatest speed is t equal 3, farthest away. Greatest velocity, we want to find the highest positive number. Remember, velocity can be positive or negative. So where is it greatest? So let's look at the graph again. It is at t equals to 0, right? We're going to find the positive one. And where else is it positive? From 5 to 6. It is at 4. If you want to sketch it how, look here. It is this positive y value furthest away, so it at 4, and then from 5 to 6 it is positive number there. On what open interval or at what time is the particle speed increasing and decreasing? So here we're going to go piece by piece again. It is speeding up where your velocity and acceleration are the same. Its speed is increasing. It's decreasing where your velocity and acceleration are different or slowing down. Another word of decreasing would be slowing down, right? So speeding up, so it will be on what intervals? Speed increasing is when velocity and acceleration are the same. So again, here velocity is positive, acceleration is negative from 0 to 1. From 1 to 3, velocity is negative, acceleration is negative, so speed is decreasing. From 3 to 4.2, velocity is negative, but acceleration is positive. And then from 4.2 to 5, your velocity is also positive, your acceleration is also positive, means speed is increasing. And from 5 to 6, your velocity is positive, but your acceleration is equal to 0 because it's at rest, so it's neither. So let's write that down. Its speed is increasing or speeding up is from 1 to 3 and 4.2 to 5, and speed decreasing is from 0 to 1 and 3 to 4.2. Okay. E, what is the particle's acceleration at t equals 4.8? Second, explain what this number means in terms of the particle's velocity. So at 4.8, I'm not asking that is it positive or negative, but I'm asking for the actual numerical value at 4.8. So how do I do that? Isn't that the average rate of change? So if I find the average rate of change of that line segment, can I not find the acceleration at 4.8? So what are we going to do is we're going to use our average rate of change. So let's do this. This would be v of 5 minus v of 3, right, over 5 minus 3, which is what? V of 5 is 4 minus negative 6 over 0.2. Just 2, not 0.2, 2, which is 10 over 2, which is 5. This is acceleration, so it'll be feet per second square. And it's asking, what does explain what it means? It means the velocity is increasing at a rate of 5 feet per second square. Okay, so on what open intervals or at what time is the acceleration of the particle the greatest? Again, acceleration is what? The derivative of velocity. Basically, I'm asking you, where is the slope steepest? Whenever the acceleration is the greatest, means I'm looking for the steepest slope. So that is between, if you look up on the graph, it is from 3 to 5. Let's write that down. That's the steepest slope we're looking for. Part G. It says, what is the particle's displacement during the 2 seconds? Justify. So here, during the 2 seconds, let's block off this area from 0 to 2, right? So would you agree that it is almost the same amount it's moving, the particle's moving to the right because it's above the x-axis, and the same amount it's moving to the left because it's below the x-axis, right? So in terms of area, if I was to talk about it in terms of area, the area of the two triangles, the area of the above triangle is same as the area of the triangle below. And if I'm moving to the right, the same amount, and then moving to the left the same amount, won't they negate each other? So resulting in a displacement of what? 0. So that was a pretty interesting question, and which we will be talking about later, but I wanted to bring up the idea of the triangles. So finish up the remaining lesson, guys. Good luck